Hello friends, today we will do matrix multiplication and its significance. In the last video we covered how to solve the linear equations in the form of the matrix. Let's start with the multiplication. Let's have two matrices. We are having two matrices here. This is matrix A and this is matrix B. These are the values of the matrix A, 1, 0, minus 3, 0, 2, 1. And the second one is B, that is 0, 1, 2, minus 1, 3, 4. First of all, there are certain restrictions while we are multiplying the matrices. The thing we should always know is that columns of the second matrix should have the same entries as the rows of the first matrix. That means these are two columns and these are two rows. This restriction is always important. Otherwise, A into B, that is AB, will not exist. Now let's start the multiplication. See, these were the two metrics that we are having. As per the rules, how we multiply is this way. This particular row will be multiplied by this particular column. Second, again this particular row will be multiplied by this column. Similarly with the second one. So we have done here 1 into 0 plus 0 into 2 plus minus 3 into 3. The second comes as 1 into 1 plus 0 into minus 1 plus minus 3 into 4. Similarly for this one, 0 into 0 plus 2 into 2 plus 1 into 3. And this one comes out to be 0 into 1 plus 2 into minus 1 plus 1 into 4. If we calculate this particular thing, that is 1 into 0, 0 plus 2 into 0, 0 plus minus 3 into 3 is minus 9. This is 1 into 1 plus 0 into minus 1 is 0 plus 4 into minus 3, 4 3 is 12. 12 minus minus 12 plus 1 is minus 11. Similarly, 0 into 0, 0 plus 2 into 2 is 7. 3 into 1 is 3. 2 into 2 is 4 plus 3 into 1 is 3 and 4 plus 3 is 7. And the second one, 0 into 1, 0. 2 into minus 1 is minus 2 plus 4 into 1 is 4. 4 minus 2 is 2. Hence, we are getting this particular answer for the multiplication of these two matrices. Just see, we started into 2 by 3 matrix and 3 by 2 matrix. And then we ended up into the third vector C, which is 2 by 2. In other words, we can say that each result cell is computed separately as a dot product of the row in the first matrix, which is a column in the second matrix. Now, let's check this. We are having this particular matrix and we are multiplying with this. What is the significance of this? See, I have three different colors which is representing my three different columns. What happens when we are multiplying this X, Y and Z? These are three different. This is a single vector which is having three entries. Now, see, this X will be multiplied by this particular column, then Y will be multiplied by this, then Z will be multiplied by this. We know the normal addition. We will normally add these vectors or the matrices and we will get a single vector or the matrix. This type of multiplication is called right multiplication. Now, let's start with the left multiplication. We are having X, Y, Z and again we are having three different vectors. I have differentiated with the different colors. See, this X is multiplied by this, Y with multiplied by this and Z with multiplied by this. And again we are having the normal addition with these three vectors or the matrices and then we are getting the single one. So this way I have graphically represented how we are doing the calculation of the multiplication. We know that whenever we do a normal multiplication, like if we are doing 3 into 2, what does this represent? It represents 3 plus 3, that is multiplying it into 2 times. That is 3 into 2 is 6 and again 3 plus 3 is 6. Similarly, if you are doing 5 into 4, what does this represent? 5 plus 5 plus 5 plus 5. Similarly, is being done with the matrices. Now let us understand this graphically. We know that whenever we are having a matrix, we can represent it in the form of the vectors. I think you should have some history about the I cap and j cap. These are the x and the y variables. If we consider it in the graph, we can say the unit vectors are, this is the I cap, this is the j cap. Now let's move on. See what happens. We are having the matrix A, B, C, D. These are the values A and C which will be represented in the I vector. And B and D will be represented as the j vector. This is the I and j. Now for example, if in place of a and c you are having the values of 1 and 1, it will be represented at this 1 and 1. This would be the point where 1 and 1 will be represented. And if the values of b and d is 2 and 1, 2 and 1, this would be a particular vector. Therefore, we have one vector this and we have one vector this. Therefore, the resultant of this particular vector will be this. Therefore, this particular matrix would be representing some vector of this form. Now, when we are multiplying this, what happens graphically? See, we are having a, b, c, d and this any other vector which we want to be multiplied with this. Now, what happens when we multiply? This x is multiplied by this and this y is multiplied by b and d. So we are getting x with the matrix of AC and y matrix of BD, and if we multiply it, we can say XA plus YB, CX plus DY. These are the normal addition that we have done. So we can say multiplying ACBD, this is ACBD, we are multiplying with XY, we are getting AX plus BY, which is same as this, CX plus DY, which is same as this. Hence, this is the way how we are doing the matrix calculation. Now, what we are doing graphically, see, for example, this particular graph we are having. When we are saying this AC, let it represent some point here. And BD, let it represent some point here. So, we are having one vector this and one vector this. And therefore, this full matrix, this particular matrix will represent somewhere this way. This would be the matrix that is being represented. Now, as we have already seen, what happens? We are multiplying this with x and we are multiplying this with y. So, we can say this was my AC, this will be multiplied at x. Let x be 2. So, this vector will be 2 times. We are having some point here. And now, let this y be 3. So, this would be 3 times. And this point would be here. Now, we are having 2 vectors, one this and one this. And this resultant of this particular vector will be somewhat this. Therefore, after multiplication of these two vectors, we will get a line this way. This is how graphically you can imagine what is multiplication. These type of formulas or this type of calculation is very much needed whenever you will see the tensor flow or any type of basic maths which is needed in the data science. So this is all about the multiplication. Thank you friends. Bye.